Bismillahirrahmanirrahim. I am Riaz Hussain Junejo and I am delivering the video lectures for the course of Applied Electricity and Electronics. Course code is CEE103. This course is being offered by the Department of Electrical and Computer Engineering, Commerce University, Islamabad, WA campus. And this course is being offered for the semester of fall 2020. And this is a series of lectures. Today we are going to have lecture number 4, and today's topic is circuit analysis. For the students information, these slides are being prepared from the textbook of Fundamentals of Electric Circuits by Alexander Sadiko. So let's start. Previously, we have studied basic terms of electric circuit, that is charge, current, voltage, power, and energy. In this lecture, we are going to discuss the basic circuit element that those elements could be present in the circuit. So let's start. From electrical point of view, there are two types of elements in the circuits. That is passive elements. Passive element cannot generate energy, but they can absorb the energy. So passive element is the element which can be excited by an external source. It cannot excite itself. It does not have any kind of energy. We say that it does not produce any energy, but it always consumes the energy. Example of the passive elements are resistors, capacitors, inductors. Just like fan is a passive element, without giving any kind of energy we cannot operate that. Similarly, a tube light, energy saver, these are some kind of passive elements. And second major type of the circuit elements is active element. Active element is an element that is capable of generating energy. Actually, it can generate electrical energy. So examples are generators, batteries, and operational amplifier. These instruments or elements can generate their own energy. They do not need any kind of external source to excite them. The most important active elements are the voltage or current sources that deliver power to the circuit. For basic circuits, we can say that basic important element is the voltage source or current source. We can easily see that in labs we have such elements, or in homes we have a main supply of the voltage or current. So there are two kinds of sources, independent sources and dependent sources. So from sources point I will say we can classify sources in two types, independent sources and dependent sources. You can guess from the name that what will be the role of independent source and what will be the role of independent source. So let's define. An ideal dependent, in fact, an ideal independent source is an active element that provides a specified voltage or current that is completely independent of other circuit elements or variables. So generally, whenever we connect an element into in circuit, if it is, let's suppose, some kind of source, so it can supply some energy. So if that energy or current, in fact voltage or current is independent of the other circuit element, then in that case we say that such source is an ideal source. An ideal independent voltage source delivers whatever current is necessary to maintain its terminal voltage. So we can define the independent voltage source as the voltage source that delivers the current, whatever current is required, but it maintains the terminal voltage. So let's suppose we have 12-volt battery. So you want to say that this is an ideal independent voltage source, so it should have the capability of delivering whatever current, maybe 5 ampere, 10 ampere, but the voltage across the terminals should remain constant. So an ideal voltage source is denoted by this symbol, that is it has two polarities, positive and negative, just like battery. And then we also use this symbol, that is two similar dashes. One dash is larger in the length and other one is smaller. Larger one shows the positive terminal and smaller shows the negative. Otherwise we can use the circle, and in that circle we use the symbol positive and negative. So this is the positive terminal and this is the negative terminal, and generally we label the voltages that particular independent source is providing. So maybe we can use here 12 volt, 5 volt, 9 volt, or whatever. So important point is that current could be whatever, but voltage across these two terminals will be fixed. So an ideal independent current source is an active element that provides a specified current completely independent of the voltage across the source. So an ideal current source is the device that provides the whatever current, maybe 10 ampere, in fact, specified amount of current, but the voltage could be different. So in this case, we denote that kind of ideal current source using arrow. This arrow shows the direction of the current, and this I denotes the amount of current that is being offered. So current will be fixed, but voltage across the terminals could be different. Then we can discuss dependent sources. An ideal dependent are controlled sources, an active element in which the source quantity is controlled by another voltage or current in the another element of the circuits. Just like we denote such sources using this diamond symbol. So if let's suppose we have some kind of dependent voltage sources, it will be denoted by V, and two polarities V, positive and negative, but you can see that this is denoted by diamond. And similarly a dependent current source or controlled current source, it will be still denoted by arrow but using diamond symbol. So this diamond shows that it is dependent, but on this circle shows that current source will be independent. So in this case, if V is not fixed, it depends on the voltage or current in the other branch of the element. So obviously there are four possible types of dependent sources. That is, first one is voltage controlled voltage source. That is, voltage of the source is controlled by the voltage and another branch of the circuit. Similarly, a current controlled voltage source. A current controlled voltage source will be a voltage source, but its voltage will be controlled by the current in another branch. Similarly, we could have voltage control current source. So we could have a current source whose current is controlled by the voltage across another element in this circuit. Or for fourth possibility is a current controlled current source. That is, we have a uh, current source, but current in this branch will be controlled or dependent on the current and in another branch. So just like here we have this circuit. In this circuit we have a fixed or an independent voltage source, and voltage across the terminals of this source is 5. This is plus terminal, this is negative terminal. We have element A, element B, and element C. So let's suppose that in element C there is current that is flowing in downward direction and its amount is I. Now in this circuit we have another voltage source. You can identify that this is voltage source because of polarities. So this is voltage source and its voltage is 10I, and I is actually current in the this C element. So you can see that the voltage of this source depends on the current of this element. So this is current controlled voltage source. So dependent sources are useful in modeling elements such as transistors, operational amplifier, and ICs. So especially electronic elements are modeled using these kind of sources, just like transistor. Transistor could be current control current device, or current control voltage device, or operational amplifier, or any kind of integrated circuit. So let's see some example. Want to calculate the power supplied or absorbed by each element in the circuit shown. So we have some kind of circuit in which we are given the current and voltage yeah, across each element, and also we are given the then that there are two sources. One is 20 volt, another is a current source, that is a constant current source. Zero point 0.2 amperes are flowing. So we want to find the power supplied or absorbed by each element in the circuit. So let's start, starting from 5 ampere current source. Uh, uh, we can see that this current source 5 ampere is coming from the positive terminal of the of a 20 volt battery. So we can say that P1, that is power delivered by this 20 volt battery, will be 20 multiplied by minus 5, or this will be minus 100. So you can see that P1 is actually minus 100. Negative sign shows that this power is being delivered by this 20 volt battery. Similarly, we can find P2, P3 and P4. For P2 and P3, the current flows from positive to negative terminal of the elements. You can see that in this element, this is positive. We are already given that this is positive terminal, this is negative, this is positive, and this is negative. And since these are passive elements, so these elements must be absorbing the power. That is, power absorbed by absorbed by these devices, our power will be positive in each case. So we can say that P2 will be equal to, since P is equal to VI, so V is equal to 12, I is equal to 5, so 12 into 5 is 60 watts. So in this case you can see that power is positive because this is the passive element. Similarly, P2 is equal to 8 into 60, that is P is equal to VI, so V is equal to 8 multiplied by 60 will be 48. Again you can see that power in this case is also positive. And finally, for P4, the voltage is 8 volt. In this case, we don't know that what is the voltage across this current source, but you can see that actually current is flowing upward direction, and this element is in parallel with this element. So actually voltage across this element will be same as voltage across this element. So voltage across this element is 8, so we can see that voltage is 8 volts. So that's why P4 will be equal to 8 multiplied by 0.2 I, and I is equal to 5, that is this is the value of I. You can see that this is actually dependent current source, and its current depend on the current and another branch. So this is current controlled current source. So this will be 8 into minus zero point 0.2 multiplied by 5, so this will be minus 8 volt. So again you can see that P4 is actually negative, so this sign shows that actually power is delivered by this device. So there are two two elements or devices, and these are actually providing the power or delivering the power, that is 20 volt and zero point 0.2 I source, and another there are two other passive elements, and these are absorbing the specified power. Electricity bill. In electricity cost depends on the amount of energy consumed in kilowatt hour, just like we mentioned in previous lecture as well. Electric in utility companies send us bill according to kilowatt hour that we consume in our homes. So in 1 kilowatt or 1 kilowatt hour is known as 1 unit of the electricity. So maybe if our bill says that we have consumed 100 units of the electricity, it means that we have consumed 100 kilowatt hour of the energy. So we can actually compute the different wattage of the appliances that we use in the home, just like water heater could be consuming 500 kilowatt per month, and freezer could be consuming 100 kilowatt or 100 watt of 100 units of the energy. Lightning could be consuming 100 kilowatt hour per month, and dishwasher 35, electric iron, TV, toaster, washing machine, stove, dryer, microwave, oven, personal computer, radio, or clock. So we can compute the kilowatt hour or units of the energy consumed by each device in 1 month, and then we can also compute the total number of units that we are consuming ourselves, and then we can compare the bill that is sent to us by the electric companies. So let's see an example. A home owner consumes 700 kilowatt hour energy in January. Determine the electricity bill for the month using the following residential rate schedule. Base monthly charge rupees 100. Let's suppose fixed, there are fixed charges of the meter or maybe something taxes. So it is, let's suppose 100, and first 100 kilowatt hour are for first 100 units per month at rupees 8 per unit. Next 200 units per month at rupees 11 per unit, and over 300 units per month at rupees 13 per unit. So want to find that what will be total cost of the electricity that is consumed by that owner who has consumed total 700 units of the electricity. So we can calculate the electricity bill as follows. Base monthly fixed charges are rupees 100. First 100 kilowatt hour at rupees 8 per unit. So this means that for first 100 cost will be 8 multiplied by 100, that is 800. Next 200 kilowatt hour at rupees 11 per kilowatt hour. So this will be 11 multiplied by I guess this should be 200. So this is 2200, and remaining 4400 kilowatt hour at rupees 13. So this will be 13 multiplied by 400. So this will be 500 2000. So total bill will be computed. We have to add all these quantities are numbers, so we can find the total number like that, and we can also find the average cost, that is total cost divided by total number of units. So we can see that how much cost we have paid on the average per unit of the electricity that is consumed by the house owner. So thank you so much. This was the fourth lecture and end of the chapter number 1. In next chapter, we'll be starting basic laws, and we'll see how we can apply those laws for the circuit analysis. Thank you so much.